Students, welcome to s.mathguru classes. Now we consider the third property of Jacobian. Third property of Jacobian. Now the property of Jacobian is third property is that if functions u, v, w are three independent variables, x, y, z are not independent, then del u, v, w by del x, y, z equal to 0. This is the property 3. Del UVW are independent but XYZ are not independent. Then if we taking Jacobian, del UVW by del XYZ equal to 0. This is the property 3. Consider one problem. If u equal to sin inverse x plus sin inverse y, v equal to x into root over 1 minus y square plus y into root over 1 minus x square, find del uv by del xy. Is UV functionally related? If so, find the relationship. So this is our problem. U given, V given, we have to find del UV by del XY, and again you have to show whether UV functionally related or not. If so, then you have to find what is the relationship. Now solution is start. So first we consider U. Here U equal to given sin inverse x plus sin inverse y. First we find del u del x. Del x sin inverse x del x sin inverse y. And this will be sin inverse x means direct formula 1 minus 1 by root over 1 minus x square, and this is 0, and this will be root over 1 minus 1 by 1 minus x square. And del u del y del y sin inverse x plus del y sin inverse y. This is 0 and this is 1 by root over 1 minus y square, and this equal to root over 1 by root over 1 minus y square. We get del u del y. Next we consider v. V equal to given x 1 minus y square plus y 1 minus root over x square, x root over 1 minus y square plus y root over 1 minus x square. Now we have to find del v del x. Del v del x del x x root over 1 minus y square del x y root over 1 minus x square. And here root over 1 minus y square is constant outside del x 1, and y is constant outside del x of this means 1 by 2 root over 1 minus x square del x 1 minus x square. We get this, and this will be 1 minus y square plus y by 2 root over 1 minus x square. This is 0 minus twice x, and 2 cancel. We get root over 1 minus y square minus xy by root over 1 minus x square. Then these two cancel. We get this one. This is del v del x. Now we have to find del v del y. Del y, and v means this one, x root over 1 minus y square del y y root over 1 minus x square. We get this. Now here x is constant, and root over this means 1 by 2 1 minus y square del y 1 minus y square, and root over 1 minus x square outside del y we get, and this is x root over 1 minus y square. This is 0 minus twice y 1 minus x square into 1. So 2 cancel minus xy by root over 1 minus y square plus root over 1 minus x square. These are the values of del v del x, del v del y. But our requirement this. Now del uv by del xy, this equal to, by definition of Jacobian, del u del x del u del y del v del x del v del y, we get this, and putting the values del u del x we know 1 by root over 1 minus x square, del u del y 1 by root over 1 minus y square, and del v del x means root over 1 minus y square minus xy root over 1 minus x square, and del v del y minus xy by root over 1 minus y square plus root over 1 minus x square, we get this one, and this is the values of del u del x del u del y del v del x del v del y. These are the values already we get. Now we expand this determinant, this into this minus this into this. So if we expand, then we get 1 by root over 1 minus x square into minus xy by root over 1 minus y square plus root over 1 minus x square minus this root over 1 minus y square minus xy by root over 1 minus x square into 1 by root over 1 minus y square. This into this minus this into this. So we get, if we multiplying this, we get minus xy by root over 1 minus x square 1 minus y square, and this multiplying we get 1, and multiplying with this we get 1, and minus minus plus xy by root over 1 minus x square root over 1 minus y square. So what we get, these are like terms, this will be cancel, 1 cancel, we get 0. So therefore we get del uv del xy, this result is 0. If this result is 0, then they are functionally related. Since del uv del xy equal to 0, therefore u and v are functionally related. If Jacobian of this 0, then u and v are functionally related. Listen, is uv functionally related? Yes, u and v are functionally related because Jacobian is 0. Next, what is the relation? If so, find the relationship. Now we consider second part. Second or third part, this second part already over. Now we get the last part we consider. If so, find the relationship. Now since we know that, what we know by the inverse trigonometric function, we know sin inverse x plus sin inverse y. By inverse trigonometric function, we know sin inverse x plus sin inverse y equal to sin inverse x into root over 1 minus y square plus y into root over 1 minus x square. We know this formula from HS second year. Inverse trigonometric function, sin inverse x plus sin inverse y equal to sin inverse x root over 1 minus y square plus y root over 1 minus x square. Now sin inverse x plus sin inverse y, this is u. this value is u, and sine inverse remains same, and this value is v. This is v given, so this is v. So this implies sine u equal to v. This is the required relation. This is the required relation between u and v. This is the required relation between u and v. This is the answer. So first we get, if Jacobian is 0, then u and v are functionally related, and the relation is that sine u equal to v. This is the required relation. Now next we consider another problem. If u equal to xy plus yz plus zx, v equal to x square plus y square plus z square, w equal to x plus y plus z, determine whether there is a functional relationships between u, v, w, and if so, find it. Functional relationship means if Jacobian is 0, then this is they have functional relationships. Now we solve this problem. First we consider u equal to given xy, yz plus zx, del u, del x, del x, xy plus yz plus zx, and this will be y into 1, yz 0, z into 1. That means y plus z we get. If we differentiate partially with respect to x, y constant, del x 1, yz constant 0, and z constant, del x 1. We get this. Del u, del y, del y, xy plus yz plus zx, and x is constant, del y 1, this is z constant, del y is 1, and this is 0, and we get x plus z. Del u, del z, del z, xy plus yz plus zx, and this is 0, y is constant, del z 1, x is constant, del z 1. So this is y plus x we get. Del u, del z is this. Now we find del v, del x. Del x, this is x square plus y square plus z square, and this will be twice x plus 0 plus 0, this is twice x. Del v, del y, this is del y, x square plus y square plus z square, this is 0, twice y plus 0, this is twice y. We get this, twice y. Then x and z constant, because it differentiate partially with respect to y. Del v, del z, del z, x square plus y square plus z square, this is 0, 0, twice z, and this will be twice z. We get this. Next, w equal to x plus y plus z, then del w, del x, del x, x plus y plus z, this is 1 plus 0 plus 0. We get this one. Del w, del y, del y, x plus y plus z, this is 0 plus 1 plus 0, this equal to 1 we get. This is 1. Del w, del z, this equal to del z, x plus y plus z, this equal to 0 plus 0 plus 1, this is 1. So all of this we get. Now our requirement Jacobian of UVW. Now del UVW del xy z. So by definition we can write del u del x del u del y del u del z, del v del x del v del y del v del z, and del w del x del w del y del w del z. This is by definition of Jacobian, we get this one. Now putting the values del u del x y plus z and del u del y, that means x plus z, and this is x plus y, del u del z x plus y, and del v del x, this is twice x, this is twice y, this is 2z, and the last one is 1 1 1, we get this. And from second row we taking 2 common. If we taking 2 common, then y plus z x plus z x plus y and x y z 1 1 1, we get this. Now we adding these 2 rows, this and this, we get r1 tends to r1 plus r2. If we adding, then we get y plus z plus x, x plus z plus y, x plus y plus z. Adding this and this, and x y z 1 1 1, these are remain same, and x plus y plus z is common, then 1 1 1 x y z 1 1 1, and this will be 2 into x plus y plus z, and this is 0 because first row and third row are identical. Since r1 and r3 are identical, these 2 rows are identical, so this value is 0. So what we get, therefore we get del uvw del xyz, this equal to 0. Therefore what we get, therefore uvw are functionally related. Whether there is a functionally relationships, yes, UVW are functionally related. The last part given, if so find it. Now second part we consider. We know that we know this formula a plus b plus c whole square equal to a square plus b square plus c square plus 2ab 2bc 2ca. We know this formula. And in place of ABC, if we write x plus y plus z, therefore this equal to x square plus y square plus z square, taking 2 common, then xy, yz, zx, and this value is, so x plus y plus z means w, this is w square, and x square y square z square means v, and x y y z zx means u. So we get this. So what we get, w square minus v minus 2w equal to 0, and this is the required relationship. This is the required relation between U V W. So this is our answer. So dear students, these are very easy solution. These are very interesting. Just practice. With practice, these are very easy. Without practice, these are very difficult. So I hope you are all enjoying with me. If you are all enjoying, then please like this video. If you are new in my channel, then please subscribe my channel and click the bell icon. Thank you.